Okay, this is our final proof example. So given x is a midpoint of wy, and given wx is congruent to yz. So I'm going to start with this one. X is the midpoint of wy. X is the midpoint of segment wy. That means that xw and yw are going to be congruent because that's the midpoint, right? We know that because there's a midpoint, we have congruent segments. Now, I could have said that because I have a midpoint, then x, right, let's see, x, yep. I could say that x is a segment bisector. That's just not useful right now, okay? So yeah, x is a segment bisector. But what I really want to do, because I have a bunch of congruent segment things, is say that because I have a midpoint, I have congruent segments. So if x is a midpoint, then I know that wx as a segment is congruent to segment xy. That's my definition of midpoint. I'm also told that wx and yz are congruent. So I think I'm going to be using transitive. I like to go underneath it when I'm going to use transitive. So wx congruent to yz, that's given. I can mark that on the diagram. So now I know wx, so 2 tick marks in green, is congruent to yz, 2 tick marks in green. And I'm trying to show that y is the midpoint of xz. So since I have these two set up to use the transitive property, wx as a segment is congruent to both xy, shown in blue, and yz, shown in green. That means they should all have all three marks, like all three of those are congruent. So specifically, I can take these other two parts then, xy and yz, make a new statement. Segment xy is congruent to segment yz. That's my transitive property. And I'm trying to show y is a midpoint. So let's go back to what we know about midpoints. We know if it's a midpoint, it has congruent segments. We also know that if we have the two congruent segments on one line segment, then we have a midpoint, because remember the converse is true. So me drawing that arrow in pink shows the converse is true. So if I have two congruent segments, okay, x, y, and y, z, now we're just looking at this space. I have two congruent segments. We just said that in statement 4. Okay, so xy's got 3 tick marks on it, yz's got 3 tick marks on it. That means that y is the midpoint of xz. And that's my definition of midpoint again. So you can use definitions and properties more than once in your proof.